Okay, so this is 4-4, and we're talking about proving triangles are congruent with the side postulate and the side angle side postulate. So we have two postulates, and they prove that triangles are congruent. All right, so here, first we have side postulate, and if you recall, a postulate is something that just makes sense. So it should be fairly obvious once I explain the postulate. Be like, yeah, why are you telling me this? All right, so you know that two triangles are congruent if corresponding sides are congruent and corresponding angles are congruent. The side postulate lets you show that two triangles are congruent if you know only that the sides of one triangle are congruent to the sides of the second triangle. So if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. Because if you have three, we'll just say three sticks, or we have, and then another that are different lengths, and then another set of three sticks that match the same lengths, you can only put them together where they meet at the same angle in the corners. Like if I have, here's this one side, and if that one's that long, the only way to make a triangle is if it goes from this end to that end. And so whatever this angle is going to be the same in the other triangle where those two pieces meet, and the same for the other two. So if all three sides are the same, the angles have to be the same. So I'm going to explain why the triangles are congruent and list their congruent sides. So here I have the given part, that side AB is congruent to DB, and it's marked with two lines. Okay, so I'm going to write that. AB is congruent to DB. And I'm also told that C is the midpoint of AD. And what do we know about midpoint? It means it's exactly in the middle. It's not just in between, but exactly in the middle. So from A to C is the same from D to C. So I can say that AC is congruent to DC. And then what about the third side of the triangle? Of each triangle, because there's two triangles. How do we know that CB is the same length as CB?
It's the same.
Because it's the same segment. Yeah. Exactly. They share that piece. So since they share it, it's the same segment. So CB is congruent to CB. All right, so I'm going to give those reasons again real quick. It's kind of like doing a proof, but not exactly. I know the first part because it was given to me. I know the next piece because that's the definition of a midpoint. And then I know the last piece because it's a shared side, or the same piece. All right, so I'm going to go ahead and write a statement that triangle ABC, remember when you write a congruency statement, it doesn't matter what order you put the first set of letters in, as long as your second set matches it. So now I have to match up A, which one goes with A and D go together, so D. B goes with B, and C goes with C. So, it's a really ugly D. So triangle ABC is congruent to triangle DBC, and that's why. Oh, by the side postulate. So by SSS. That is how I know. Okay, so that's side. All in all, we're going to have 5 of these postulates. Today I'm only going over 2, and then on Thursday we're going to go over the other 3. But these 2 will give you a good start. They're the easier ones. It's nice to start off with the easy ones, right? Alright, so the other one that we're going over today is the side angle side postulate, SAS. And it says if 2 sides and the included angle, not just any angle, but the included angle, whoa, of one triangle are congruent to 2 sides and the included angle, of another triangle, then the triangles are congruent. So you have to have 2 sides and the angle in between those 2 sides. So not just any angle in the triangle marked as congruent, but the specific one is right there in between. So you can tell by looking at the abbreviation SAS, the A is touching both S's. So side, angle, side. The angle is touching both of the sides. So it has to be in the middle. Alright, so we're going to explain why the triangles are congruent and list the congruent parts. Okay, so we have that DF is congruent to JH because it's marked with 1 line. And trying to figure out which order to put the letters in. Again, it doesn't matter with the first one, but with the first one I decided to start at D, and I went towards F, and F is the 90 degree, the one that's marked 90 degrees. So on the other triangle, if I would have to start at J and go towards the 90 degrees also. So that's why I said it the way I did, that DF is congruent to JH. I could have said it the other way around, that FD is congruent to HJ. It's the same thing, but I do have to match the order of the second set to the order of the first set. Let's see, next I have a 90 degree angle at F and a 90 degree angle at H. So angle F is congruent to angle H because they're both 90 degrees. And then I have this other one marked with 2 lines. This one's marked with 2 lines. So from F to E would be the same as from H to G. So FE is congruent to HG. So that's the parts that I have listed as being congruent. So if I want to check which postulate it is, the green mark marks a side, so I put an S. The little box marks an angle, so I'm going to put an A. And then the 2 lines mark an S, so I put another, it marks a side, so I put another S. And so looking at it, if you read in a circle, it doesn't matter if you read clockwise or counterclockwise. Side, angle, side. Now some of them, like on Thursday, we're going to have angle, angle, side, and that's not the same forwards and backwards. So if you read it backwards, then it's the same thing. I don't know. That probably didn't make any sense. I'll explain that in the next lesson. Okay, but you can't just check one. You do have to make sure that they're both marked in the same order. So again, I have a side, an angle, and a side, and I can see that my angle is in between the 2 S's. My A is between the S's. So I'm going to go ahead and write a statement. that triangle FDE is congruent to triangle, let's see, if I started with F, I need to start with HJ. HJG by SAS. So the two triangles are congruent by the side angle side postulate. All right. And then we just have examples from there. So we're going to do some practice problems like your assignment. First, it says for each diagram, determine if each pair is congruent and by which postulate. So we have three possible answers: side, 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 angle, side, or not congruent. All right, so looking at each one. Here we have a side marked, and there's another one marked with one line. Then we have a side marked with two lines and another side marked with two lines. And then they share a side, WY or YW. We can mark that with three lines because it's a shared side. That's the most common one to miss. Maybe because it's the most simple and so it's overlooked. So if you see a shared side, go ahead and mark a shared side. And then let's label. We'll start with the bottom triangle. Doesn't really matter where, just marking sides and angles. I have three sides, so it's side, side, side. The other one, label it, side, side, side. So this is congruent. So it's congruent by side, side, side. Every once in a while, I've seen a few problems come up where they're not marked with the same thing, but they both have, most of the time they are, one or the other, and you just figure it out. But every once in a while there's a sneaky question in there, and like one of them will be a postulate, and then the other triangle won't be, because it'll be in the wrong order. Okay, number 2. We have a shared side, so I'm going to start there with two lines. And here's a side marked with one line and a side marked with one line. And then I have an angle, M, an angle, T. That's everything that's marked, and I don't see any other relationships that I know, because you can also use other postulates and theorems that you know, or we've gone over. You can use those also, but I don't see any others in this one. So we have an angle, we have a side, and we have a side. We have an angle, a side, and a side. So if that was a postulate, that would be the SSS postulate, and that's not a postulate. That's never a correct answer, okay? So this is not congruent. All right, and if you read it the other way, it's SSA, and that's also not one. All right, so the next one, moving along. We have a shared side, so I want to go ahead and mark that. Mark it with two lines because there's nothing marked with two lines. HK has a single line. KL has a single line. Angle K has one line on both versions of angle K. So when I mark the sides and angles inside, I have a side, an angle, and then a side. There's no gaps between the sides and the angles. I didn't skip any pieces. So side, angle, side. So this is congruent by side, angle, side. So like if I, for example, let's say it was, real quick, just for an example, if that line was over here instead, and so my angle was down there, I would expect someone to say, well, why not side, angle, side? But it doesn't work like that, because then I just skipped a whole nother side and a whole nother angle to get to the side. So you can't skip over pieces whenever you're trying to figure out the sides and the angles for your postulate. They have to be right there in order. All right, so I'm going to get rid of that and mark this again. All right. 3 more. Let's see, what do we have? Single line, double line, double line, angle, angle. So we have a side, an angle, and a side. Side, angle, side. So this one, yes, it is congruent. There's no gaps between the side, angle, side. It's congruent by side, angle, side. Number 7 looks a little odd. You mark it first and then I'll go over it. So the single line and the single line. So if we're looking at the KNL triangle, the one that's standing upright, if that triangle was pushed over on its side, then you would have the other one. But this line right here, because it looks like it's on both of them, but it's not. It's really just marking the bottom of the one that's been pushed over. Okay, and then 2 lines and 2 lines. And let's do green. There's an angle, and there's an angle. So now let's see if they make up an order that is a postulate. There's an angle, there's a side, there's a side. There's an angle, a side, and a side. So this would be the ASS postulate or the SSA postulate. Nope. That's not a postulate. So this is not congruent. These are not congruent. It doesn't matter that they look like they are. We don't, and they may be, we just don't have enough information given to say that they are. We can't prove it. And the last one, again, we have a single line, single line. We have 90 degrees, and what's special about whenever you have a line or an angle that's marked 90 degrees and it continues on, it means the other side is also 90 degrees.
And also as of 180, right?
Yes, because of the straight angle is 180. So if 90 degrees is one side, that's half of it. So the other side is also 90.
And also triangles out of 180, right?
Mm-hmm. That is true. And then they have a shared side. So now we'll label the pieces. There's a side, there's a side, there's an angle. There's a side, there's a side, there's an angle. And then when we go to read it, side, angle, side, and we didn't skip any pieces. So this is side, angle, side postulate. So these are congruent. This is congruent by SAS, side, angle, side. Okay, so then the last part is state what additional information is required in order to know that the triangles are congruent for the reason given. So there's not enough information here, but it's asking what else do you need to know? Well, if I have 2 lines and 2 lines and 3 lines and 3 lines, that just means I need the other side to match if it's side, 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 side. If it's side, side, side means all 3 sides are congruent. I do need to make sure I get this in the correct order. So if I start at L and go to J, L is the angle next to the 3 lines. So in my other triangle, I find the 3 lines. That's by Z, and then it goes towards X. So that's what's tricky here, is you have to make sure you list the letters in the correct order. So L, we need to know that segment LJ is congruent to segment ZX. Or I could have said it the other way around. Segment JL is congruent to segment XZ. Just want to list them in the correct order. And then for the other one, I have 2 lines and 2 lines. Actually, I'm going to go and mark those. I think the copies didn't really turn out that well on your paper. So I'm going to go ahead and emphasize where those are at. 2 lines and 2 lines. Okay, so on the next one, it gave me 2 lines here and 2 lines here. That's all it gave me. That's a side angle side. Any ideas on what I would do here? Does that shape look familiar at all?
Oh yeah, vertical.
Yes, very good. It's vertical angles. So you can apply other postulates or theorems that you already know. We already know that vertical angles are congruent. And those are vertical angles. They're V's that share the vertex. V's that share a vertex are vertical. They also make that bow tie shape. So we already know that. So that's not additional information needed. But given what we know, we have a side. Now we have an angle. So that means we need the immediate next side, so that angle is included. And here it would be side, angle, side. So we need to know that these two pieces are congruent. And we need to order them in the correct order. So QR is congruent to QL. Or RQ congruent to LQ. Either way.